Yeah, in the last class, I have already talked about the derivative of vector function and the geometric meaning of the derivative. So let me go through that first. So given a curve, uh, given curve in the space, right? So you can describe it using the vector equation. Okay, so r over t, x over t here, y over t, z over t. This is a vector equation for this curve C. Okay. Now what I just said is a vector equation because for the same curve you can have many vector equations to describe it. You can have many vector equations to describe it. Okay. Imagine this is going to be, just put in a moving object along the curve. You can move faster, can slow, but still have the same object, right? So to the location of the object at the time t, it gives you the vector, gives you a vector function, and this is also called the vector equation for the curve. Okay, so r over t, okay, here r over t can be viewed as, is position function of a moving object on C. Okay. 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 So how do you find the derivative is going to be the derivative is going to be is the derivative of each component. Okay. So it's easy to find the derivative of vector function. Okay. This vector functions can be also called vector equation for the curve. Okay. So this vector function, you can find the derivative. When you differentiate, you just differentiate each component. Okay. So what is the geometric meaning of this derivative? Okay. If this is a curve again, here this is and going in that direction, right? So the derivative, okay, this is origin, right? This is r, okay? And when you differentiate, you get another vector. What you got here, if you want to draw the vector, this is a vector always start from the origin, okay? And so this is a derivative, okay? But if you parallel moved it to that point, okay, physically, then r prime t can be viewed as a tangent vector, okay? So r prime t is a tangent vector to the curve C at the point of t, okay? Okay. Now, if you just want to draw the vector for r prime, so usually when you draw it, you start, the starting point will be the origin, okay? And then you draw the curve. And but what's the definition of vector? Well, the vector, a definition of vector and how to draw it in the space in physics, let's say a vector, is an object in the space and have a starting point and ending point, right? And all the vectors parallel to each other are viewed as the same vector. Okay, you can put at different location. Okay, but if you give three numbers put together, okay, you can call the vector when you draw it. You always if you don't know the starting point, you just draw from the origin. Okay. All right. Then this is called a tangent vector. Okay. Why is it tangent vector? There's a reason that. Okay. The reason is how do you get this? Right. This is a t at the time t, right? And here's this is r over t. this is r of t plus h. H is an arbitrary small number. Then you use the difference. R prime t is going to be the limit h approaches 0 over t plus h, right? So r over t plus h minus r over t is this vector from, right? Okay. Is this vector, but divided by h, then it could be, it could be longer, right? Otherwise, without the h in the denominator, then when h approaches 0, this is getting smaller and smaller, so the limit will be 0. So if you divide by h, and this this will approach us a vector, but that vector, it's reasonable to call it tangent vector, okay? Yeah. All right, now, so that is the tangent vector, but tangent vector depends on, another physical meaning of this tangent vector is, and this is a velocity vector, okay, of a moving object at a time t. Okay, if you view it as a moving object, then the object moves faster, then you have a velocity vector longer, and if it moves slower, then velocity vector will be shorter. Okay, so in general, this is a length. The length is going to be square root of x prime t square and the y prime t square and z prime t square. And this one is not necessary to be constant. Okay, this can be this is if r prime t is called a velocity vector, then this is also the length of the velocity vector is also called a speed. Okay, this is also called a speed. That's all we need to know about basic information. So let's do some exercise. All right, so this is the first example. All right, so we are given a vector equation over t, and that is going to be e to the power t and the 2t and 0, right? So this is simply written as this can be also written I plus 2tj, and that third term is 0k, right? K is 0 times k. And let's find out the derivative, okay? So the derivative just differentiates component, and you get this, okay? And so at the time t equals 0, right? And R0 is going to be e to the 0, 2 times 0, 0, and that's going to be 1, 0, 0, okay? And R prime 0 is going to be e to the 0 and the 2, 0. So it's going to be 1, 2, and 0. Now let me try to, it's hard to draw the picture. Yeah, it's not easy to draw a picture, okay? But I can draw it later, okay? So I just want to draw the point, okay? 1, 0, 0 is here. So here's the axis, the y-axis, z-axis. So this is a 1, 0, 0. That's the point. And R prime 0 is going to be 1 and 2, right? So so if you draw the vector R prime 0, the starting point is from the origin. And this is a vector. I'm going to draw the vector using red color, okay? So 1 and 2, so 0. This is a vector 1, 2, 0. But we're talking about the tangent vector, right? So you can move it to this side, okay? So this is the R prime. And the curve may be, let's see, the curve, how does the curve look like? Right? I can, using, yeah, so here's x is going to be e to the t, y is going to be 2t, right? Z is going to be 0, okay? Now you can find the relationship between x and y. Because t is half of y, so this implies x is going to be e to the half of y, okay? So this is a parabola, no, exponential function, okay? So is this, if this is y-axis, it looks like that, right? It's in the xy plane always, right? And it's exponential growth, right? So it's passing through that point. That's why the tangent vector to the curve at that particular point looks like that. It matches with what we got. So this is at the point when t equals 0. And when t equals 0, the point has components 1, 0, 0. Okay? Yeah. Yeah, sometimes you can express the relation between x and y without by eliminating the parameter t. Okay? So I think we completed the problem, finished the problem already. Yeah, we're given vector function, vector equation for the curve. It's not necessary to draw it, the whole curve, okay? But we are lucky here we can able to draw it, okay? So we are asked to find the position of the point when t equals 0. And if it's a moving object, then find the velocity vector, okay? If it's just a curve, we use this vector equation to find the tangent vector. Okay? Then since we can have the parametric equations, right, for the same curve, and since those functions are simple, so we can find the relation between x and y. Then you realize that the curve should be a graph on the xy plane, which is graph of an exponential function. Okay. Now, if you just want to draw, this is an axis, this is y-axis, right? If you want to draw the graph of this, right? How do you do that, right? So when y is negative, this x is almost 0. So this graph looks like that, okay? Right, the exponential growth. Okay, you can also change it to, you put a natural log, and y is going to be twice of the natural log of x. That's it. Okay. But 3D picture is much harder to draw it because two-dimensional plane, right? It's not easy to draw a three-dimensional thing. I think I taught this course before in the last spring. I find out the students have trouble to draw the graph, especially draw the surfaces. So this I don't know how. Yeah. How do I get e to that? Okay, that's a good question. You see, y equals 2t. So I solve for t. T equals half of y. Then x is equal to t, so e to the half of y. Just eliminate the variable t. Okay, good question. Let's try another problem. Okay. Okay. So given a vector equation for a curve, we're going to find this. Okay. So all I have to do is just find the derivative of each component. So e to the negative t is negative e to the negative t, and the 1 minus 3t squared, and here's 1 over t. Okay. This is clearly defined for t greater than 0, okay, because natural log of t is not going to be defined for t less than or equal to 0. Okay. It's not easy to draw the graph. Okay. So we can also take a look at when t equals 1. T cannot be 0, right? Then r over 1 is going to be e to the negative 1. 1 minus 1 squared is going to be 0. And natural log of 1 is also 0. So this is a special point. And the derivative is negative. And it's 1 is negative 2. And here's 1. Okay. Okay. Alright, so now can you draw the picture? Yeah. Somebody's calling on her class. All right, so let's draw the graph. Okay. So first of all, you find the point r over 1. Right. This is going to be somewhere here. Right. E to the negative 1, 0, 0. Again. Now another point, you have to how to draw it. The first component is negative. The second component is also negative. And the third component is positive. Right. So it goes like that. Up a little bit. Right? So this is, think about, right? So here's a negative 2. No, this is the negative e to the negative 1. And this is going to be negative 2. And this would be 1. Okay? So the vector will be like that if you start from the origin. Okay? Now you have to parallel translate it here if you want to say this is a tangent vector. Okay? Right? Parallel translate here. The curve, maybe the curve passes through that point in this way. We don't know. But at least I can tell that the tangent vector. Okay? Right? So this is what I wanted to try to draw. Okay? If you just look at this vector, how to draw it? It's always starting from the origin. And the tip of the vector is components negative e to the negative 1, negative 2, and 1. Okay? But if you want to say this is going to be tangent vector to the curve, then the starting point will be from the point. Right? The starting point will be from the point. Okay? Right, so let's take a look at next problem. So this time we're going to find tangent vector, which should be find the tangent vector. So r over t is going to be r over t is going to be cosine t, 3t, and the 2 sine 2t. Okay, find the unit tangent vector capital T at t equals 0. Now what does that mean? All right, first of all, yeah, you don't need to draw the graph, but unless it's required. It says sketch the position vector and the tangent vector. If you look at the problem, then you should sketch the graph, okay? If it's not, yeah, if you're not asked to do that, you don't need to do that, okay? Right.
Would you be able to read your example again? I cannot read R of t.
Oh, so this is a cosine t, comma, 3t, and a 2 sine 2t. Okay, this is from the problem number 19 in the book. Okay. So we are given this vector, we are given this vector equation for the curve. We don't need to draw the curve, okay? And what we have to find out is that there's a unit tangent vector. Now, what is a unit tangent vector? First of all, you get the tangent vector, okay? R prime t, you find out. But this is not necessary to be unit vector. The length could be different from 1, okay? Then it's going to be negative sine t, 3, and when you differentiate the third one, it will be 2 times 2 is 4 cosine 2t, okay? Right? But this one, it's not necessarily a unit vector. So the unit vector by definition is going to be the vector divided by its length, okay? Now, this is going to be a unit vector, okay? Because when you remember any number, a vector, right? And this is going to be the absolute value of the number and the length. So this is a vector, then, right? So, so A of this is going to be viewed as, right? So when you take the norm, yeah, you find the norm, right? It's going to be the absolute value of this and that. So it's going to be 1. So this always be a unit vector. Right? So all I have to do is find the length. The length is going to be square root of the squares of each component, add them together. So negative sine t squared, 3 squared, and 4 cosine 2t squared. I'm not sure we can simplify it. Does not look like it. We do our best, okay, to simplify it. It's going to be sine squared t, and here's 9. Sine cosine 2t. Well, cosine 2t is just cosine 2t, right? If you don't like the cosine 2t, the possible formula you can use is 1 minus 2 sine squared t, or 2 cosine squared t minus 1. So, so you get 4 square, 1 minus 2 sine squared t, and the square. I don't think that we are going to simplify it further. You can multiply this out. You can express it in terms of a sine t, right? Sine t, okay? And that's possible, right? Yeah, we can try a little bit. So it's 9, here's 16, 1 minus 4 sine squared t, and sine to the 4th power, okay? So the constant 9 plus 16 is 25, and then minus 36, 1 minus this is 35 sine squared t plus 16 sine to the 4th power t. So that's it, I cannot make it. So then the tangent vector is going to be, this should be going to the denominator. Okay, And what is the derivative? Derivative is negative sine t, 3, and 4 cosine 2t. So this is a general formula. But what we want is to do together is when at t equals 0. Okay, when t equals 0, and this is just a square root of 25, because sine 0 is going to be 0. And here is 0, 3, and the cosine 0 is 1, so it's 4. Okay, cosine 2 times 0, cosine 0 is 1. Okay, so the answer will be, it's 105,034. Okay, so that's it. So you can also express it in this form, 3/5 and 4/5. So that's that is going to be the unit tangent of that. Okay. In we skip the chapter 12 because this is just a review, right? So given a vector A, have components A1, A2, A3, and B, B1, B2, B3, and we can define the cross product. I define the product. Okay, so it's called the product two vectors. This is will be another vector. How do you understand that vector? So this is going to be, here's A, here's a B. Right? To get the vector, this is going to be, you use a right hand, noted from A to B, and this is going to be the vector. Okay. And now all you need, this is how do we define. Then all you need to know is what is the length of that. Okay, what is the length of that? The length of this is going to be depends on the angle, right? The angle sine theta. If this is a theta, okay, the length. First of all, I can tell you the direction, right? This is a perpendicular to A and B, and the direction will be determined by the right hand. Okay, and the length is going to be the length of A times the length of B times sine theta. Okay, and this is different from the dot product. The dot product is just a number. Okay, it is going to be the length and the cosine theta. Okay, so there is a small a difference. And so in order to get a vector perpendicular to two given vector, you look at the product of two vectors. Okay, right? So the product vector is always perpendicular to them. Now question, how do you find it? Okay, how to find it? And you can find it in the following way, formally, and you can, this is IJK. So A1, A2, A3, B1, B2, B3. Okay, this is a determinant, but here the first row are just the vectors, just as a formal notation. Okay, so this will be A2, A3, B2, B3, and I minus and A1, B1, A3, B3J, and the last one will be A1, A2, B1, B2, and K. Okay, the three components. And I guarantee this one is perpendicular to A and perpendicular to B. Okay, so this is a formula, and the product dot, this the product, perpendicular means the dot product with A is going to be 0, okay? And the dot product with B is also 0, okay? Now, what is dot product? Okay, dot product is going to be just A1, B1, A2, B2, A3, B3, it's just a number, okay? And those are those are stuff we learned from chapter 12, which we did not cover, okay? All right, so let's take a look at the following example. So we are given a vector equation for a curve to t and e to the negative 2t, t e to the 2t, okay? All right, what I'm trying to do is I want to find out and we can also find this, okay? And yeah.
Could you read the R of t, please, again?
R of t is e to the 2t, comma, e to the negative 2t, and t times e to the 2t.
Thank you.
Yeah. So now here involves second derivative, just the same way to do that. Just differentiate the first derivative. Okay. So if this is a curve, and this will be capital T as unit vector, but R prime T could be long, could be short. Okay. R double prime T, we don't know. Maybe in that direction. Maybe like this. Okay. Okay, let's try to find the R prime T first. So we differentiate each term is 2e to the 2t, negative e to the negative 2t, right? And then here's a bit complicated, the product rule, first e to the 2t plus 2t e to the 2t. Okay. So that's what you get. Okay. All right, now in order to find the tangent vector, unit tangent, this is tangent vector already, right? When you differentiate. The unit tangent vector, you have to find the length. Okay. It will be, so it looks like a complicated 2e to the 2t square, negative 2e to the negative 2t square, plus, okay. But remember, you will see that I cannot take all the terms out because e to the 2t here and e to the negative 2t. So it's not the same term. You're not able to simplify it. All you have to do is just, do some calculation here. So 4e to the negative, so this will be 4, negative 4t. And here e to the 4t, and the 1 plus 2t squared. I don't think I'm going to simplify it further. Okay, so capital T is just now when we in the book we at T0, and maybe maybe it'll be much easier, right? So usually you're given a special point. And in this case, e to the 0 is, yeah, this is just only 1, right? Okay. Then the length is going to be just 2 square, negative 2 square plus 1 square, then much easier, you know. So 2 times 2, 4 plus 4, right? 4 plus 4 plus 1, it's going to square 9, it's going to be just 3. Right? 4 plus 4 is 8, 8 plus 1 is 9. Okay, so the unit tangent vector will be this. Okay. All right. Now, what I have to do, I have to find the second derivative of the function. Okay, the second derivative function. The function is already above that, so I can. Yeah, I need to copy the function here. Okay, let's find the second derivative. So 4e to the 2t. It's also 4 e to the negative 2t. This one's a little bit complicated. I'm going to write e to the 2t here. Then I differentiate this by product rule. Then plus 4t to the 2t. So actually I got 4e to the 2t plus 4te to the 2t. Okay. So this is the second layer. Okay. All right, so let's evaluate at the t equals 0. Okay, at t equals 0. Okay. At t equals 0, yeah, let me copy this again. 2, negative 2, and 1, right? And r double prime is 0. It's going to be 4 and the 4 and just 4. Okay. So let's take a look at the cross product. How to find the cross product? Well, you can write, if you know how to find the derivative of the 3 by 3 matrix. Yeah, this is how do we write. Okay. And the first component I is a negative 2, 1, 4, 4 I. The second component is 2, 4, 1, 4 j. And the third component, okay, and then in the middle, we have to change the sign, okay? So here I got negative 12i, 8, yeah, and this one is negative 4j, because 2 times 4 is 8, 8 minus 4 is 4. And this will be 8 minus negative 8, so it'll be 16k, okay? So this is a vector. Now you can check that this vector is perpendicular to each of them. Okay, you can check that. So this is just cross part. Now there's a reason why we had to do the cross part. Okay, that's always the next topic in section 13.3.
Is that 10K or 16K?
Yeah, we so the geometry meaning of the second derivative is not clear. Okay, but the cross product gives you some good meaning, because if the okay, here's the point. Okay, let me show you. So if r prime t, the length is always equal to 1. Okay, this is a curve. Okay, let me show you. Okay, this is a, so this special vector equation, okay, and so the tangent vector has a unit length, okay, then you will see that you will see that the product is going to be 1, right? Dot product. So you differentiate. There are certain rules you have to follow when you differentiate. It's called the product rule, which is given, called differentiation rules. I'm not going to mention that over and over again. So it's given in the book, okay? So when you differentiate both sides, this is just like a product rule, okay? If you differentiate both sides, then according to the product rule, so this is second derivative, and switch the order, and it's going to be 0. So, and those two terms can be commutative because can be exchanged because this is a dot product. So you get twice of this. Okay? So that indicates if the speed is if the velocity vector is a unit vector, then this will be perpendicular to the tangent. Okay. So in this case, but this is not necessarily to be unit vector, but it's perpendicular. Okay. Okay. Now, if it's perpendicular, then what happens? Okay, this is another vector, okay, which is perpendicular to both of them. So you get 3 vectors perpendicular to each other. Okay, this will be like that, rotating in this direction. So this is a vector r prime t, r double prime t. Okay, so those 3 vectors are perpendicular to each other. So if you have a vector equation for the curve, and it has a unit tangent vector, then you can get 3 vectors perpendicular to each other naturally at that particular point. Okay, they're not necessary to have a unit length, except for the first one, the tangent vector is unit length, but the second derivative does not have a unit length. Okay, but the second derivative, the length of the second derivative tells you, okay, how curve of the curve at that particular point. And we are going to understand the meaning of this, okay? And this, the derivative, the length, in this case, the length of the second derivative has a geometric meaning here. That's called curvature of the curve at that particular point. That's what we're going to talk about later, okay? Okay, so this is, so now we're going to find the vector equations. Okay. All right, so we find the parametric equations for the tangent line to the curve. Yeah, so maybe you can try that. Find the parametric equations for the tangent line, okay? To the curve. The curve is given by x equals square root t squared plus 3, and the y equals natural log t squared plus 3, and z is going to be t at the point 2, natural log of 4, and 1. Okay? Okay, so think about this, whether you are able to solve it. Any ideas?
what do you call the first derivative divided by the magnitude of the first derivative?
Yeah, the magnitude in mathematics is called the norm of the vector. Yeah, this is called the unit tangent vector. Okay, unit tangent vector. The derivative is a tangent vector. Okay, but if you divide it by its magnitude, that's going to be, you make it you modify it to a unit vector. So that's why I call unit tangent vector. Otherwise, you don't need to say unit tangent vector, just a tangent vector. Okay. And here we're going to find parametric equations for the tangent line at that particular point. Now, how do you get the general formula first? You have to have some good ideas first, right? So this is a particular point that's called A, okay? And if we can figure out a tangent vector, right, then the parametric equations, now we have to use a different notation if we already use RT for the vector, okay? I'm going to use I don't know what I'm going to use. All right, so the tangent vector, a vector equation for the tangent line is going to be A plus T and V. Okay, so this is a vector equation for the tangent line. Once you get a vector equation for the tangent line, you can get a parametric equation for the tangent line. Okay, you should have a clear picture first, and then what is A, right? A is going to be already given 2 natural log of 4 and 1. Okay. Now all we needed to find the tangent vector V. Okay. V is going to be the derivative of each component. So the question is, what is that, right? I already used R over T for the vector equations. So I'm going to describe this curve by a different notation. Yeah, this is going to be, yeah, let's say just use a C over T, okay? So C over T is going to be X over T, so T squared plus 3, and the natural log of T squared plus 3, and T, okay? So the tangent vector, okay, is going to be, you just differentiate. Okay, so you differentiate the first one. This is going to be T over square of 3 and the T, okay? Now I just write down the derivative. It's using the chain rule to find the derivative, okay? And this will be T squared plus 3, and that will be 2T here, actually. Okay, the other one is just not 2T because there is another 2 canceled out, and this is a 1. So this is a tangent vector, okay, at the particular point. So here, what is a V? V is going to be C prime at the point, right? We have to find out T. So when, for what T, yeah, you have to figure it out. This is a C of some number, T, right? So when I look at the picture, I think it should be C of 1. Okay, because when T equals 1, that's a square root of 4 is 2, right? Natural log of 4 is, yeah, it's natural 4, and that should be 1. So this should be 1, right? Okay. So that is going to be 1 over square root of 4, that's 2. And here 2 over 4 and 1, right? So simplify it. Right. So you get this. All right, so once you figured out the tangent vector, then you can write out the equation, okay? So that is again 2 natural log of 4, 1, plus t, 1/2, 1/2, and the 1. Now, this is a vector equation for the tangent line. Okay? Then the parametric equation would be x equals 2 plus half of t. Y equals, because you can combine them, x, y, z, right? So y is going to be natural log of 4 plus half of t. And z is going to be 1 plus t. Okay, so those are parametric equations for the curve.
Is x equal 1/3? Is that 1/3t?
Yeah, x is 1/2 times t.
All right, thank
You
you.
know, you added the corresponding components together, right? So those two.
Yeah, I was just not being able to read, but that too. I thought it's 3.
Okay. Yeah, just combine them. Okay. Now, when you differentiate, you can differentiate a vector function, but you can also integrate a vector function. So if r over t is going to be x over t, y over t, z over t, then you can integrate, okay? Indefinite integral or definite integral doesn't matter. If it's indefinite integral, it's going to be just integrate each of the component. Okay? And we also have the fundamental theory of calculus. So that is if a capital R prime t equals little over t, then the definite integral of this is going to be capital B minus capital I. Okay, so this is for fundamental calculus. Okay, so just the integral. Now, well, now let's try. Yeah, let's take a look at this next problem. So R over t is 2 cosine t I plus sine of tj plus 2tk. Okay, so let's find out this indefinite integral. So just evaluate each, sorry. So integrate each function. Don't forget dt, okay? dt is just part of the integral. Okay, so the antiderivative of cosine 2 will be sine t, so 2 sine t. Now, you may have a coefficient that's called C1, I. So integral of sine t will be negative cosine t, then have a C2, j. Integral of 2t is t squared plus C3, okay. Right? Then you can combine them, 2 sine t I negative cosine tj plus t squared k plus a constant vector. And this constant vector is just C1i, C2j, C3k. Yeah, the meaning of this integral, it's not clear yet. Okay, It's not like the derivative, you know, we clear that the derivative is going to be the tangent vector to the curve, okay? Different parametric, different vector equation for the curve gives you different tangent vectors. But if you normalize that, okay, then you get the same unit tangent vector, okay? And so the geometry mean is very clear to the derivative. The integral, this moment, it is not very clear. Okay, so we just learn, you know, this. We just learn the formula how to evaluate the integral of a vector function. Okay, we also have the fundamental theorem for calculus for the integral. If the vector function is going to be, well, if the vector function is a derivative of another vector function, then you have a above formula. Now, integral, okay, according to the above formula, right? Let's look at this. Okay, according to the fundamental theorem of calculus, this is going to be R of B minus R of A. Now, what does that mean? Let me explain to you. The integral of tangent vector as a vector function, okay, is going to be the difference of two positions. So you can get the information about the position, okay? So this is a starting point, t equals A, it's going right here, okay? This is when t equals B is here. So this is R of A, this is R of B, and the difference is going to be that vector, okay? So along this curve, you have a tangent vector, okay? So the integral, if you given me the information about the tangent vector, what I can recover is the difference of the two position vector, okay? The difference of two position vector. That's what the theorem tells me, okay? So if you tell me, hey, I don't know the position vector for the moving object, but I know the velocity vector that is given. That's what I deducted. Okay, so let's integrate. We integrate this derivative, and then we end up with the difference of this two position vector. Okay, the starting point and the ending point. Okay, that's what you can get. Okay, and if the curve is a closed curve, okay, so it's a return to the origin, right? Like that. Okay? Then you will see that this is starting point, t equals A, also t equals B. Okay, it's closed. Then the integral of the if R of A equals R of B, the orbit of the moving object is closed. Then the integral of the velocity vector is going to be 0. Okay? It's 0 because the difference is 0. Right, so when it's returned to the original place, okay, and then this is going to be 0. So that's probably, you know, that's where the use of the integral. Okay. So if you give me that, if you told me this is a closed curve, and yet you know I'm given the tangent vector function, okay, then the integral of the tangent vector function will be 0, must be 0. Okay, so that's all we need to know. Okay, I stop here, and my next class will be on length of the curve and the curvature. Okay, and so given a curve in the space, we have to tell how curved the curve is, right? At some particular point, you cannot say, oh, this is more curved than the other one. And we need a quantity to describe it. That quantity is called the curvature. That's for one curve. But for surface, we also need a curvature to describe how curved the surface at that particular point, right? And if you have an eye exam, the new equipment, they even tell you the eyeball, the curvature, that tells you that your eyeball, whether it's deformed or not, change the shape, So this is the quantity we use to measure the surface, okay? So we needed to understand the curvature, the meaning of curvature. So especially you're the mechanical engineering and you're trying to design some surface of, design some object, the surface, like airplane, the surface of air, right? So sometimes you have to say, hey, that part of the curvature is what, you have some quantity to measure, okay? So this is this course is very important especially for the mechanical engineering students, if you want to go up to graduate level, graduate school, okay? I think it's less important for electronic engineering. It's more important for mechanical engineering, okay? Especially fluid mechanics. But I'm going to stop here and see you Monday.
I have a quick question.